Yeah, so hey Nandini, welcome to today's class. In today's class, we'll be talking about insertion and deletion. Well, this will be our final operation on arrays. We'll be learning how to perform insertion and deletion in both one-dimensional as well as in two-dimensional arrays. So I'll be also introducing you how to read two-dimensional arrays. Okay, now insertion, talking about insertion, right? Insertion is basically adding elements to an array. Now, how do you do that? One-dimensional array, you basically run a loop. Till now, what we have learned in our classes where we were using for loops. So with for loops, there was one variable which was able to access each index values of an array. So traversing through each cells of an array, we were able to reach on to each indexes and input the value to those respective index. That is how we were used to do in a for loop. So that is basically how insertion works. There is a for loop which keeps on running from 0 to n minus 1 or 1 to n, depending on the conditions that you specify. And based on each index value, you are inserting those values. Okay. So as you can see in one-dimensional array, you have this in the figure which is being shown to your bottom left. There's this one-dimensional array which goes down. So a of 0 is having value 1, integer 1. Then a of 1 is having 2. Similarly, it goes on. Now, when we want to insert an element in an array, so what happens is imagine your assembly line, okay? When you stand in an assembly, there is a queue. So imagine one class, let it be 10A. So a class of 10A is having 10 students. So they are standing one after the other, right? Now, if somebody needs to join in to 10A, suppose there are 10 students present, one person is coming late. So what does he do? He stands back, right? He stands at the end of the array. So considering that to an array, so if we need to enter an element, if there is sufficient space available, so a new element is occupying the last index. For example, if your index is 4, the last final index is 4. As per in this example, it shows final index is 4. Now, if I need to enter a new element, I have to do it at the index 5. Okay, that will be the easiest way of inserting an element. But there might be situations where I need to insert those elements at a specific location. For example, let's say in your assembly line, you are being asked to stand in this ascending order from height wise. So what do you need to do? The person who came late has to come front. So in that situation, what happens is when he is coming in between, so there is a distortion in between, right? So when he's replacing somebody, now what should that somebody do? He cannot go back because we want it in an ascending order. The queue, the assembly line, we want it in ascending order. So what he does is he joins in between, and all those people standing next to him, after him, have to take a step back or have to move forward. Okay. In arrays, we say we have to move to a next house or to the next index. Now, for example, now if I need to add an element called as 6 at index 2, so I cannot replace 2 with 6. Okay. Now I cannot replace the value the index 2 with 6 directly because there is already 3. If I do that, the element 3 will be lost completely, and I don't want that to happen. Or neither can I swap the positions of element 3 and element 6. Right? So what will I do is I will I will make all those elements who are already present from index 2 to move on to the next house. For example, that means now at index 2, we have element 3 which is present. So I will move, so I will work on the final. I cannot start it in between. So at my final index, I have element 5. Now I will shift this element 5 to index 5. Consequently, I will shift element 4 from index 3 to 4. Then element 3 from index 2 to 3. Then I'll have an array which will look like 1, 2, 3, 3, 4, 5. So there's a repetition of 3 and 3 in index 2 as well as in index 3. So even if one index having value 3 is lost, that is not going to affect me. So what will I do is wherever position now I'll bring that 6. My objective was to place the element 6 at index 2. Now I will bring my index value 6 and place it or replace it with index 2. So I will have an array of 1, 2, 6, 3, 4, 5. Understood?
So basically, you'll be able to insert an element only if there's space in the array, right?
Exactly. And that is why generally when you see an array declaration, you find like we declare an array of 100 size, but we don't use a of 100. Generally, when we perform any operations, we declare a larger array. Our objective is so that the space shouldn't fall low. There should be sufficient space available for us to add further more values because arrays are static. Once we declare it, we cannot change the size again. We cannot go back and change the size. So we give sufficient, we just assume we try our level best to give the sufficient space as possible in the beginning itself.
Just a question, not related to this concept.
Okay.
I'm not very sure about that also. There's something called the global declaration also, right? So what if we declare the size in the global declaration? That can be altered, right?
Global declaration happens with global variables. Okay, it's you can declare an array globally. So what is global declaration means is that segment, whatever you write in the global declaration, that becomes accessible throughout the program. So there is something called as local declaration and global declaration, local access and global access. We will talk about that. Let's not deviate from this topic. I will surely tell you about that. Okay. So for now, are you clear with the idea? So if you need to insert an element in between, so all those, the neighbor element should be shifted with 1 plus index size. Okay. Okay, yeah, so this is what I have told you. Now, if we have an array, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At position 5, I need to insert this new value 50. So what I'm doing is I'm not replacing it. Okay, I'm not replacing this X value with this 5. Reason being, the value 5 will be lost, will be completely lost if I replace it. So what I'm doing is I'm moving all those elements like from 5 to 10 to a 1 plus index size. Instead of next index, neighboring index, consecutive neighboring index. And I'm replacing that position with my value. Okay. So this is how basically you can insert an array in your specific position. Now, talking about two-dimensional array. This is the first conversation about two-dimensional array. Well, two-dimensional arrays are nothing but a matrix. Now, how do you number a matrix? How do you access a matrix? Now, each matrix will have rows and columns, right? We have rows and columns in our matrices. So each cell in a matrix will be represented by its respective row and column. Now, for example, if we consider here, we have 0th row and 0th column. So the first cell, very first cell of this matrix will be 0 and 0. When we move here, the row still remains the same, which is 0, but the column is 1. And so the index cell values will be 0 and 1. So this is similar. That is what we are going to implement in the program also. We are in a previous examples, in a previous one-dimensional array, there was only one variable which we were using to iterate and move forward. But in two-dimensional, what happens is one single element is not sufficient because there is not just one single column or one single row. Here, there is the concept of both rows as well as columns. So we need two variables. So we'll be requiring two variables. Now see, the loop runs when all this thing is happening in the for loop. So there are two loops. One loop here for rows and one loop here for columns. So you use I to iterate through the rows and you use J to iterate it through the columns. So this is a basic general assumption. You can actually change the variables, but in generally we represent it like that. So if you see a declaration of A of I and J, A of I, comma J, so that refers to a two-dimensional array. Okay, if you see two variables in an array, that means it is two-dimensional by default. Okay, so what happens is you have two loops. So what is happening in the first loop, the outer one, okay, your row, see this row minus one, you're running your loop from 0 to row minus one. This one, we call it as outer loop. Okay, this is an outer loop, and within this loop, you are running the column loop. So what will happen is, now let us say your first thing will be 0, because your first index is 0, 0 to n minus 1. So your 0th row will be selected. Okay, this row, this entire row, 1 and 2, we are not bothered right now. Your 0th row with this entire row, which is available here, will be selected. Now, if your row is selected, now you need to just iterate it through the columns. See here in the example in step 1, your first row 0 is selected. Then what happens is you go to the inner loop, inner for loop, which is a J loop. Then you iterate it to the number of columns. Okay, and that is when, and you can see the value of I and J need not to be perfectly same. Okay, it need not to be a perfect square matrix. Okay, I and J, the number of I is 3, the number of J is 4. So it is having 3 rows and 4 columns. Okay, so you need, it's not necessary that I and J value has to be same. So what happens to your inside for loop is, now your this row is selected. Once this row is selected, you use your second for loop to traverse to the number of columns and insert the values. So your first row will be filled. So it's not like 1, 2, 3. So your first row will be filled in the first step. Okay. So now when you traverse to the columns, okay, column 0 will be filled. So 0 of 0, yeah, you're inserting the value 1. So 0 of 1, 2, 0 of 2, 3, 0 of 3, 4. Once you have iterated, you have reached to the n minus 1, this for loop comes to an end. But your outer for loop is still running. It has still traversed only 0, 0th index. It hasn't reached n minus 1. So it moves on to the further step of n minus I plus plus. So your first row is finished. It moves on to the second row. Okay. Second row, once your second row, it reaches to the second row. Again, it goes inside the for loop, inner for loop for the column. And your second row has been filled. So 1 of 0, 1 of 1, 1 of 2, and 1 of 3. After reaching here, again, n minus 1. So your column, all the columns of the second row are filled. It has reached n minus 1. That loop ends. But exterior loop is still running. So it increments the I value and you reach to your final column. Final row, which is 2. So 2 of 0, 2 of 1, 2 of 2, and 2 of 3. Once you reach this, yeah, your exterior, your inner loop ends. Also, your outer loop also ends because you have reached to n minus 1, which is 2 in this case. Once both the loop ends, all the elements of the array are filled, then you print or do whatever operations you desire. Okay, is this clear?
What if I want to insert one element somewhere in between? Is that possible in a two-dimensional?
Yes, it is possible, but in that scenario, you need to specifically give an order. For example, A of 1, 1. So A of 1, 1, this will be filled. Okay. Whereas your other elements will be replaced with 0 because you haven't filled anything. So in that scenario.
No, like imagine this is my, like right now in step 3, whatever array is there, that is my array already.
Okay.
I want to insert a new value in A of 1, 1. Will that be possible?
Yes, you can insert a new value, but this value which is already existing, that is 10, will be erased. What you can do is you
But
can
the whole
yeah, okay.
yeah, so I'm
Go
sorry.
on. Go on.
But the whole point of insertion is to keep moving the elements forward and not erasing anything, right?
That is why what you can do is you can store it in your separate variable. What you can do is you can have a temporary variable that will store the value 10. let's say a variable A. Now that will be storing the value 10. And you can replace this with 20. So 20 will be there and your value will still be there. So, but what you can see, as I said, you can only do that when you actually have space. But as you can see, all the elements are filled here. All the cells of this array, two-dimensional array, are filled. So there is no space. And in order to create a space, you need to declare your I and j value accordingly. Here, what I have done is I have just given you an example. Okay, example with 3 rows and 4 columns. Now, if you're declaring 100, 100, A of square bracket 100, 100, so you'll have 100 rows and 100 columns. So based on your conditions, you are just traversing it. Okay. Is your doubt clear?
Yes, sir.
Okay, then. Okay, now moving on to deletion. Now, what does deletion mean? So if you have an array, you're removing an element. Now, similarly to what we have learned in insertion, deletion can also happen at specific location or at the end. So, but deletion generally happens at specific location, right? Because if you have an array and you found out that this value shouldn't be at this index, I have inserted in wrong value. So we generally edit it or delete it. So, but the problem is if we delete that element, the value is lost completely. So at a later stage, if I require to read that value, what am I supposed to do? So in that situation, we keep that value in a separate variable, and then we delete it. Also, when we delete an element, we in the initial classes, what did I say? We need to save space and time, space complexity and time complexity. Now, if I'm deleting that element, that value, that space is wasted. So what I do is, if I'm deleting an element at a particular location, let's say, suppose if we have this array of A of 5 with 0, 1, 2, 3, 4 index. Now, if I need to delete this element 4, what am I going to do is, I am going to, okay, I'll delete this element, but I will bring this 5. So if I delete this element, this 4, right, will be lost. So I will save it in a temporary variable. That is my first step. And if I delete this, the memory will be wasted. The space will remain empty. And that leads to a wastage of memory. So what will I do is, I will shift this element, the next element, to that position which I have deleted, the element which I'm currently deleting, and I will reduce the size of the array by -1. Okay. Logically thinking, if you have 5 elements, if you delete one element, there are only 4 elements left. So the compiler shouldn't get confused that, okay, where is the next element? So there are only 5 elements, only 4 elements. Why is the array size 5? Okay. So this is how it's happening. Any doubts with this? You're
No, sir,
basically
it's clear.
you're basically deleting it from that location. And deleting in the sense is just like you're replacing the value 4 with 5. Okay. And you're reducing the size by 1. That's all.
And we're also saving the value 4 somewhere in the
Yes.
temporary
You are
variable,
saving
right?
that deleted value with a different variable. Okay. In a different variable so that the data is actually not lost. Now, talking about deletion in two-dimensional arrays. Well, it's almost the same. So what you do, the different concept in two-dimensional array is you actually don't delete any particular element in two-dimensional array, because when you declare a memory block to I into j, rows into columns, that entire memory block is reserved. So it's not like you can remove a cell in between. Okay. So what we do is, if we need to delete an element in a two-dimensional matrix, we replace that value with 0. Now here, for example, I need to replace this value, which is row 1 and column 2. So I will initialize matrix name, let it be matrix A of 1, 2, double equals to 0. So what I'm doing is I am replacing this value which is present here at this location with 0. So this is what deletion means in two-dimensional array. Now, if you need to save this value, yes, you can save it in a temporary variable or do whatever operation that is necessary. So here what you need to understand is deletion in two-dimensional array is nothing but replacing them with the value 0. Any doubts?
No, sir.
Okay. So with this, we conclude our arrays concept. We have completed all the operations, learned about different sorting, searching, insertion, deletion, traversing, array operations, all those by now. So I assume all the concepts of arrays, all the operations of arrays would have been clear by now.
Yes, sir, it's all clear.
Great.